What's up everybody, today I'll show you how to implement the ESP-NOW protocol with the unidirectional communication. And so for this project you'll need just two ESP32, the model doesn't matter. First you need to enable the TCP IP stack on both of them. You can do that by configuring them as a station or as an access point. I actually recommend configuring them as a station because an access point consumes more resources, obviously. And so, let me show you what functions you'll need for this project. First, you need to initialize the TCP IP stack, obviously, so we'll set them as a star init. Then we need to initialize the ESP-NOW protocol. Now we need to set a callback function, which will be triggered after the transmission and after the reception of the data. We will set a TX callback on the TX side and the RX callback on the RX side. And by doing that, you will be able to read the received data in the RX side. And on the TX side, the TX callback will let you know that the transmission has ended. At this point, you'll need the transmitter ESP32 know that the receiver exists. And the only thing that the transmitter needs to send the data to the other ESP32 module is its MAC address and the channel that they are communicating on. And so we will use the function that adds a peer. A peer is basically a connected device in the local network. So basically we will add the peer and then we'll simply send the data. The data will be sent, for instance, hello world, and after that there will be two function triggers, as I have already told you. The TX callback on the TX side and the RX callback on the RX side, obviously. And that's pretty much it. I really like this protocol because it only uses the ESP module and it's way better than the NRF24 modules. The communication range of this protocol can get up to 500 meters if you're using the long range feature. And let's get started. And just to let you know, I have started a free embedded systems community in which you can network with like-minded individuals, share your projects, your thoughts, ask questions. Here I will be hosting a lot of webinars, so I can't wait to see you in. We are already 21 members in, so you'll have the link in the description. Now let's open VS Code and make sure you have the ESP-IDF extension installed. You can find it over here just by searching ESP-IDF. Alright, I have already installed it. And so let's create two projects. One for the RX and one for the TX. And so go to the ESP-IDF extension and create two projects. Name them whatever you want, it doesn't matter for now. The boards that I will be using are two ESP32C6. Alright, open it in a new window. Keep it like this. And let's create another one. Now that I have created both of them, I'll write the code that I have already shown you. It's not that complicated. Alright, let me show what I have done here. And so, here's the transmission callback. I'll simply print something on the terminal, such as TX callback. Here I initialize the TCP IP stack. Remember, I don't connect it to any network. I only initialize the TCP IP stack, only the network interface. And so I initialize the network interface, the default parameters, I set it as a station, I set the I set the storage to RAM, no power saving, I set the channel to 1 because I want to communicate on the channel 1, as I have already told you. Now there's one more thing to do. I'll need to retrieve the MAC address from the receiver in order to let the transmitter know who is it sending to. Alright, I will just flash the program. Let me see. I'll open the console, and as you can see, this is the MAC address of the receiver. I'll just copy it on the TX side and let's see if the transmission works. I have finished writing the code for both of them, so let's flash them. Let me show you the boards that I'm using. So this is the TX and this is the RX. Alright, let us see. And as you can see, the receiver is receiving perfectly fine the data. And so, don't forget to join my school community. You will get a free embedded C course when you get in there. I'll see you guys later.